weight is greater than 1.800 pounds. So that's our alternative, and that's our claim. The null then would be mu equals 0.800. Okay, so we have those. Okay, we'll do this one both ways, and we'll switch to just using the calculator. Okay, so we need our critical value. We have a right tail test. So 0.05 goes in here. So that means 0.95 is the area to the left. So 0.9500 is 1.645. Whoops, it's a t-test. I need to be careful about that. Alright, so our area to the right is 0.05. Degrees of freedom is 61. So area in one tail is 0.05. We want 61 degrees of freedom. Now, you'll notice the table doesn't have 61, but 60 would be close enough, so we'll just use that one. 1.671. It's our critical T. Okay. Now what we want to do is find the value of our test statistic. So we want to take our mean from our sample minus the mean from the hypothesis test, the null hypothesis test, times the square root of 62, square root of n, over our standard deviation. Okay, so this is our test statistic. Okay, so 1.911 minus 1.8 times the square root of 62 divided by 1.065. And I'm getting 0.821. Go ahead and put the 1 in there. So our test statistic is going to be over, so we'll fail to reject. The null hypothesis. So if we go to our 391 for our wording, okay, the original claim does not contain the equality. It's the alternative hypothesis is the claim. And we fail to reject, so it's the second case. There is not sufficient evidence to support the claim that there is not sufficient evidence to support the claim that the mean weight, and I'm taking this directly from the problem, the mean weight of discarded plastic from the population of households is greater than 1.800 pounds. Okay, so that's the critical value method. Now, if you wanted to do it by the p-value, we can use the calculator to do DCDF 1.671 to 10, degrees of freedom would be 61. So the calculator is a little more exact than the table in the back. So second vars, we want number 5, and it's 1.671, comma, 10, comma, 61. Close it off, and we get 0.0499 as our p-value. And we can see our p-value is very close to our alpha. So if we rounded it to 2 significant digits, we would get 0.05. So it's greater than or equal to, or 0.05. Okay, p-value greater than 0.10. Was I supposed to use a 90% confidence? Let's see. Equals 0.05. Okay, they're getting a different p-value from technology, so let's do it with the calculator so that I'm making sure I'm doing everything right. Okay, so let's do the, okay, it was a right tail test. Let me see if I can get it to work this way, and then we'll move on to the second way I know it'll work. Alright, so we're going from our test statistic, which was 0.821, comma, that's what I did wrong, I didn't use 0.810, comma, degrees of freedom would be, we had 62, so that's 61. 0.2074 is what I'm getting there. The book is saying 0.2075. So that is bigger than our alpha, which is only 0.05. So we're going to fail to reject the two. So 0.2074. All right. P value 0.74, and that will lead us to the same conclusion. Now another way to get the p-value is to do the entire hypothesis test on the calculator, and I'm going to clear off. Let me clear here as well. So if you're going to do the whole hypothesis test on the calculator, we want to go over to tests, and we want the t-test, which is number 2. We're going to put in stats, so we're going to select that. Alright, mu sub 0 is the mean that comes, whoops, I went too quickly for myself. The mean that comes from the null hypothesis, and that was the 1.8 pounds. Alright, the mean from the sample was 1.911. The standard deviation was 1.065. Our n was 62. And we wanted to test the greater than, was our alternative. To want to go down. Trying to get it to go down to calculate. For some reason the program is not working. Let me open a second version here. 48, so that means degrees of freedom would be 47. Use alpha equals 0.01 significance level to test the claim that the mean departure delay time for all such flights is less than 12 minutes. Okay. That's our claim. So that means the mean is equal to 12 minutes. So this one's going to be a left-tailed test. So 0.01 is what goes in here. Okay, and so if we use our table for our critical value, degrees of freedom is 47. Okay, it looks like 45 is the closest to that, and in one tail we have 0.01. So I'm getting 45 is the closest, so I'm getting 2.412. 412. Okay. Okay. So we want now is we need the value of our test statistic. So we want to take our 10.5 minus the 12 times the square root of 48 over 30.8. Alright, so 10.5 minus 12 times the square root of 48 divided by 30.8. I'm getting negative 0.337. That's going to be a negative. So that one also is failed to reject. The null hypothesis. So our wording would be there is not sufficient. There is not sufficient evidence to support the claim that the mean departure delay time for all such flights is less than 12 minutes. So the flight manager would not be justified, flight operations manager would not be justified in reporting that. Okay, and our p-value, I'm just going to do it on my calculator, I won't use the screen calculator, is the TCDF, and we're going from this time negative 10, since we're in the negative, to a negative 0.337, and our degrees of freedom is 47. So let's see, second bars to get our, we want number 5, and I want negative 10, comma, negative 0.337, comma, 47, close it off. And for the p-value, I'm getting 0.3688. So certainly that is greater than our alpha. So again, it would lead us to fail to reject. And let me double check here and make sure I got the right p-value. Okay, they have 0.3687. So close enough for what we need here.